we're back. So homework 1 is due Thursday by 11:59 p.m. So that's parts A and B. Remember, part A, you have like 30 online questions to do, and then you have like 5 just handwritten to me due on Blackboard. That's part B. All from the same textbook and everything. So the problems aren't too different. I didn't mention this last time, but please show all your work in part B. Obviously, you can't show your part in part A because that is on WebAssign. It's just type a question. But like the whole point of you turning in problems to me on WebAssign, not WebAssign, to Blackboard, is so that I can make sure that your work follows and that you're justifying getting your answer correctly instead of just like kind of doing crazy math and just happening to get the answer, right? So yeah, that homework is due on Thursday. Make sure that you are checking your emails, right? I send out announcements on Blackboard and then those are sent directly to your emails. But if you forget or lose an email, announcements are just like saved up on Blackboard. So I sent out a big email about the homework and please show your work, but I'm reiterating it now just in case some of you, I don't know why, but I don't know. I always check my email. So just please always check your email. And then exit slips. I haven't been getting a lot of you, like 8 or 9 of you not doing exit slips or people showing up and then just hanging around at the end of class and not doing your exit slips. Exit slips serve 2 purposes. 1, to track attendance. Literally, you are attending, not just turning on Zoom and walking away for an hour and a half. That you're actually like attending and paying attention. And then for me, so that I can actually make sure that when you are paying attention, all the material is going in and you're feeling good about it and stuff like that. All right. So exit slips are not optional. They are 5% of your grade. So please remember that. If you're ever concerned about an exit slip not going through, email me and I can just double check. If you go through and complete it, it's there. And if for some reason you have something where you can't come to class that day, just email me. I understand if for some reason you have some special event, I don't know. But like, it's just email me, right? It's okay to like miss a class or 2. You don't have to come to every single class, but let me know so that you don't miss points on your exit slip. Okay? And then today we are going to do B.2 and hopefully start and finish B.3. Okay? So let's hop over here. So remember B.2 was all about factoring expressions. So factoring going from polynomial all the way to factors, or remember things multiplied by each other. All right, so we talked about factoring out common factors. And then we talked about factoring by grouping, where I just take 2 terms are added and subtracted from each other, and I put them in their own little groups. And then I use factoring by common factors via grouping, and then I do it again. And that's a fun way of factoring. We also learned the AC method, which seems tedious, but over time it gets better, right? So if we have the AC method comes from finding factors of A times C right down here. I might use my pointer right there. So I need to find 2 numbers, we call them D and E, and they're going to be factors of A times C. And then I can narrow down that list by finding the 2 that add to B. Okay? And then I replace B in my polynomial with D plus E. So I'll get something that kind of looks like this. I distribute my X to D and E. And then I factor via grouping. So I'm going to put A and D together and E and X together. Sorry, E and X, EX plus C. My goodness. And group it that way. It doesn't matter if you do D plus E, E plus D, the factors will still work out. And then we went through some fun examples. Okay. Any questions so far before we continue on with notes? Okay, great. Thank you. So sometimes we can do trial and error to come up with practice, right? Kind of how we were talking about last time. Oh my God, this whole page is so long. With factors of 45, right? We had 9 and 5. We had -9, -5, and we worked through all of this. So if I'm trying to find things that factor 2x squared plus 11x minus 6, I have a lot of different options, right? I want things, I think this is how I learned to factor. If I like kind of started like this, because I know 2x times x, and then I would just sit here and be like, okay, what if I do things that multiply to -6? What about 2 and 3? Well, then that doesn't work because what does that equal? 2x squared plus 2x minus 3x minus 6. So I got these two to match, but this is equal to what? -x. And I want positive 11x. That didn't really work. So what if I tried to switch -3 and x plus 2? Well, again, that doesn't work. I'm still getting the beginning and the end, but I'm not getting that middle piece that helps us narrow it down, right? B. So like B would be like 11 right here. And I want to find two numbers that add to it. And then those two numbers are factors of what? -12, which is A times C. So what's another guess that we can just go off, knowing that these two don't work? Let me finish factoring this out so we can prove that it doesn't work. What's another educated guess we can make? X minus 3. We already did an x minus 3, and that didn't work. What are some other guesses to factor this one? Six and -1, right? I can try 2x, what, minus 6, and x plus 1. And then remember, I can FOIL in fact to double check. So 2x squared minus 6x plus 2x plus 1. That doesn't get, oh, not plus 1. Sorry, minus 6 again. So this right here is going to give me -4x. So yeah, well, let's switch it. So 2x minus 1 x, not minus 1. Yeah, plus 6. So I get 2x squared minus x plus 12x minus 6, which is 2x squared plus 11x minus 6. Cha-ching. So it took a while to check and guess, but it is an option. But imagine doing that when we had like 15 and if it's a good question, Tucker. Do we have to use the AC method? If a problem asks you to do a problem using a specific method, we'll get into like other ways of like solving quadratics via different methods. If the method is specified, you do have to use that method. So if I ask you to factor via grouping, factor via grouping. If I ask you to factor using the AC method, use the AC method. But I will say, if you can choose whatever you want, factor using any method you'd like. You don't have to use the AC method. Does that make sense? That's a good question. Yeah. It's a useful tool to know, but checking and guessing is still an option, just which one is going to be more time consuming. All right. So let's move on to some fun definitions. So we say that a polynomial is irreducible if we can't factor it, or it can't be factored, right? And we'll go over it in a little second. Okay, yeah. We say that a polynomial is factored completely if its products, if it's a product of irreducible polynomials, and we'll go over what that means in a second, right? So irreducible, I can't factor it. Not everything can be factored. So I have a few examples, like x squared minus 1. Can I factor that? Do you guys know? Griffin says yes, right? This is actually, we'll learn this in a second, called the difference of squares, right? X squared and 1 is a square. Difference means subtraction, right? It's x minus 1, x plus 1. Thus, it is not irreducible. Okay. Not very good at spelling, so I really have to sound out words. Okay. What about ax plus b, where x is our variable and a and b are just random numbers? Do we think that's irreducible or factored completely? Yes to. I guess irreducible and factored completely. Wrong question. That's a bad question. It is irreducible, aka technically you can also say you can't factor it anymore, right? So if I have like x plus 1, right, where a is 1, b is 1, that's irreducible. It's already factored enough. I can't factor, there's no common anything in x and 1. Same with x minus 1. So we would say this one, x squared minus 1, when I write it like this, is factored completely. So that's what I mean by saying it's product of irreducible polynomials. These guys each are irreducible, right? So whenever, if I have like 3x plus 4, irreducible. What about x squared plus 1? Irreducible or not? Kerman says no. Does anyone think that we can factor x squared plus 1? Okay, so it is irreducible. And if irreducible sounds like a weird word, it has the word reduce in it. So I can't make it smaller. I can't break it down into these other bite-sized pieces. So ir, that IR suffix, is like a negation. So I can't reduce it down to its factors. It's a good way to think about it. If I wanted to factor x squared plus 1, I would get roots equal to plus or minus I, which is the square root of negative, not negative I, of negative 1. And those are imaginary numbers, and we don't deal with imaginary numbers in this class. So if I'm going to get something with a negative under a square root, I'm going to assume I did something wrong. All right. Any questions about irreducibility? Okay. Whee. So now we're asked to factor the following completely. Well, a little confusing. Will we have to be able to tell them apart? What do you mean tell them apart? Like if something is irreducible versus reducible? Yes, and once we talk about how to solve quadratics, you will learn more tools to figure out if they're irreducible or not. But for the main part, if I try to factor it and I get something crazy, or the roots are imaginary numbers, it's going to be irreducible. So if your AC method isn't working by grouping and everything, it'll be kind of clear if it's not irreducible, if that makes sense. Okay. All right, cool. So let's practice factoring these guys. These look a little different than what we've kind of been working with. Right now I have, well, first I have W in this one, but I have W to the 4th power. We've kind of only been dealing with X squared. But I think that we'll be able to do it. All right. So just looking at 2W to the 4th minus 32, what's something I can do first to factor this? Right, greatest common factor. I was jaded and then Ronald follows up, but that we're going to take out the 2. So perfect. So if I pull out a 2, I'm going to have W to the 4th minus 16. I have an anti-dog running around the house. What else do we think we can do next to simplify and factor these guys completely? Take the negative out, square. What do you mean by take the negative out? What do you mean square? Okay, so we want, wouldn't the 2 be gone? Where would the 2 go? We're working with an expression, not an equation. So numbers can't disappear. All right, so let's go back to our AC method, right? What would A be if I'm looking at W to the 4th minus 16? Let's spell it out. A equals B equals. Careful. A, B, and C are numbers, not variables. So we already pulled the 2 out. So we're kind of, we don't really care about that 2 now. We're just working on this, right? It's going to be 1. So even though this is W to the 4th, we can think of it as 2 W squared squared minus 16. So it's still X squared, or X maybe W squared, something like that. What about B? What's B? 0. Great. And what about C? Negative 16. So I want to find D and E that multiply to be negative 16 and add to 0. What are some options? Four and negative 4, right? If you weren't really sure, we can always like solve. So like D, like negative E, and then you could just like plug it in there, blah, blah, blah. It's really fun. Okay. So we get that D is going to be 4, E, negative 4. Remember, I'm plugging that in for B. So if I were to rewrite this, this would look like 2, like W squared, just to make it look a little nicer, plus 4 minus 4x minus, oh, not x, excuse me. Would I put W or W squared here? If I'm dealing with W to the 4th, which is also W squared, is this going to be W or W squared? Why can't I say what? Okay. Don't know what we're talking about. So this is going to be W squared, right? So if you want to think about if X equals W squared, right? If X squared then would equal W to the 4th, right? So this is W to the 4th. Instead of X, I have W squared, okay? Oops, and that's a 16. Great. And then we're going to, so that would be equal to W to the 4th plus 4 to the W squared minus 4W squared minus 16. We're going to group them together. I get W to the 4th. Oops. 1 second. Let's group them together in this box. So I'm going to group together these two and these two, but I'm going to add a plus right there just so we don't get confused with this negative, because that negative is going to go to that and make that a negative appear. Is that clear why I'm doing that? Because it would make it look like this: 2W to the 4th plus 4W squared minus 4W squared plus 16. Right? If I distribute back this negative, I get that negative 4 and a negative 16. I have to be careful with that, all right? Cool. What am I going to pull out of my first group? Right, I'm going to pull out W squared. So I have W squared plus 4. What about my second group? Right, 4. W squared plus 4. Great, I did something right because I still have this common factor. So I can do once more. W squared plus 4. I'm going to pull that out of each term. And I'm going to be left with W squared minus 4. Great. Are we done? Did I completely factor this polynomial? Ronald says yes. Does anyone say no? You all are incorrect. So notice here, I have w to the fourth minus 16. I have something squared minus something squared. It's okay, Abby. W minus 4, I also have something squared minus something squared. This is called difference of squares, and we're going to learn this in a little bit. But I can factor w squared minus 4. So you need to look at each factor too. Okay, I can't reduce 2 anymore. W squared plus 4, I would try to do the AC method and I wouldn't get anything, but w squared minus 4, I would. So I have to do it one more time. Who thinks they know what w squared minus 4 can factor into? Duke, you're fine. Remember, we can kind of also like guess. What are things that multiply to negative 4? Yeah, 2 and positive. Negative 2 and positive 2. So w minus 2 and w plus 2. Beautiful. Now are we done? Is it now factored completely? Yes, it is. Unbox my answer because I am so happy with it. Whee. A quick way to see if something is irreducible, like these kind of cute 2 terms ones, is if its roots are imaginary. Like I said, if I get a negative under that square root, then it's going to be irreducible. If the roots are real, I can reduce it. We'll learn more techniques as we move on to the next sections. I believe in C2, we learn about completing or like solving quadratics. And that's another tool that helps. Why is it not explained earlier? I don't know. Okay. We're going to hold off on this example because it deals with cubes and we haven't learned that yet, and I don't think that's very fair. Squares I can get away with because the AC method works. Cubes, a little bit not. All right. So any questions about the problem that we just did? And then a follow-up. How are we feeling about irreducibility and like factoring again when I have a little bit more than x squared? So I have something to the fourth. Thumbs up, thumbs down, or thumbs sideways. How are we feeling? I have a thumbs up. Yes, everything we learn is on homeworks. Low sideways, I respect that. Sideways, yeah. Once we go over the fun little rules about this, I think it'll be better. I always mean to switch these. If you're asked to do the AC method, I would do that. If you have, I know there's lots of different ways to factor. So, but you need to check each term. Sorry, not term, factor, to make sure that that factor is then also factored completely. Class recordings are always on Blackboard under lecture recordings or recorded lectures, and they're also always on my YouTube channel, which you can find on the syllabus. Okay, so we're going to skip number 2 and come back to that one. So we have some fun special factoring formulas. And these will help a lot with irreducibility. So these are common factorizations you should know. You will see in here that I'm not using any X's or anything because I could easily write it like above how I had like w to the fourth minus 1. Duke, you need to calm down. Or something random like that. So a could equal like 2x something, right? So then a squared would equal 4x squared. That's what a and b can equal. They can not just equal numbers, but also expressions like this, okay? So if I write a squared minus b squared, I can quickly factor that into a plus b, a minus b. We call this one the difference of squares. So that's how above I knew that it wasn't going, what was it? W squared minus 4 could be factored more, but W plus 4 could not. W squared plus 4. So that's the difference of squares. A plus B, A minus B. The second one is that A squared plus 2 AB, oh my gosh, plus B squared. That's going to factor to A plus B squared. That one doesn't have a fun name. Similarly, instead of if I changed that addition to a subtraction, I would have A squared minus 2AB plus B squared. And you can always double check that by foiling each of these terms. And let's do that really quickly because you cannot distribute an exponent over addition. If you do, I'll be really upset with you. Right, so A plus B squared means A plus B. A plus B. FOIL means first, so A and A. O, outer, A and B. Inner, B and A, which is the same as A and B. And last, B squared. These are the same term, so I can collect them and call it 2AB plus B squared, which does not equal A squared plus B squared. That most of the time is irreducible. Okay. Any questions about these fun factoring formulas? I'm not going to ask you what the difference of squares is. I might. But these are tools that you should know. They're going to make it a lot easier. And they're really easy to spot because they all contain perfect squares, right? So I know I'm going to have, if my constant term at the end is a square, that's going to give me the lead to look at the other two parts of the equation to see if I can use any of these, okay? So let's do an example. So we're asked to factor 4x squared minus 1. Which one of these factorizations do you guys think it's going to be? 1, 2, or 3? Why is that, Ronald? Careful, -1 isn't a perfect square. 1 is a perfect square. So you're correct, 4x squared is a perfect square, right? It's 2x squared minus 1 squared. 1 is a perfect square. All right. Well, then that helps me look over here. So it's that thing squared, something squared minus something else squared. And then I take those two somethings and I add them together and I subtract them from each other. So I'm going to take 2x plus 1, so a plus b, and 2x minus 1. All right. And if you're never sure if you're like, oh, is it b minus a? Which one is it? FOIL and double check yourself. You have a whole week to do homework, 24 hours to do an exam. You can take a few extra seconds to FOIL something out and double check your work. Okay. Any questions about that problem? Okay. Remember, if you have a question that you might not be like very confident on asking publicly in the chat, you can always individually message me and let me know. It's like passing a note to me in class, and I like won't ever like out you. Be like, oh, this person asked me a question. Like I won't do that. Same with if you're thumbs up and thumbs down. All right, cool. So now we have 4x squared minus 28x plus 49. So I know 49, oh my God. From my times table, I know that is 7 squared, and I know 4x squared is the quantity 2x squared. All right. So that's a good indication that I need to check this middle guy and make sure that it is equivalent to one of these two middle terms. Does that make sense? How to use these product formulas? And by all means, when you're doing your homework, have these with you. Practicing with the notes instead of sitting there confused. Yeah, practicing with the notes is better. Okay. So which out of these factorings do you guys think I'm going to use? 1, 2, or 3? Abby, why do you say 3? Why are we choosing 3? Right, because there's that negative right there. Great. So I can rewrite just how I rewrote 4x squared minus 1. I'm going to rewrite 4x squared minus 28x plus 49 to kind of match what 3 looks like. So I know I can write 4x squared as 2x, the quantity squared. And I know I'm going to want to write minus 2 times something, probably 2x, times something else, plus 7 squared. And that 7 is what's going to help me. Then I can double check. 7 times 2 is 14, times 2 again, just 28. So I know I did the formula right. All right, and then I go up and check here. Okay, I'm going to take 2x minus 7, and I'm going to square it. Right, yeah. If anytime I want to check these, just FOIL it out. So the best part about these problems is there's a way to check your answer. Just make sure you're good at FOILing. Okay. Any questions about how are you guys feeling about these 3 factoring formulas? Thumbs up, thumbs sideways, or thumbs down? I will say difference of squares is a lot easier to see than the other 2. They don't have a fun name. But again, seeing that I have my constant number as a square number is a great place to start to like check on it. Same with this guy as well. Okay. Now we have difference and sum of cubes. These are a little longer. So above, if I had a squared plus b squared, that I can't, that's irreducible. But now sum of cubes, I can reduce it down. So I can factor it completely. All right, so let's start with difference of cubes. So a squared minus, not a squared, a cubed minus b cubed is going to equal a minus b, a squared plus ab plus b squared. Careful, this guy's different than what we looked up at above, right? This, I could factor this if was a 2 right there, but I don't have a 2. And I'm going to tell you right now that both of those quadratics are irreducible. Okay? If I have sum of cubes, I'm going to have a plus b, a squared minus ab plus b squared. Obviously, difference in sum of cubes is a lot easier to see because you have 2 terms. These are kind of confusing to remember, and this is actually a mnemonic that I learned teaching last semester, and now I never forget it. And it's called SOAP. So it stands for same. So your first, see how it matches this pattern a squared, ab, b squared. And then the only thing that's changing is the signs. Do you see that? So SOAP says that my first sign is going to be the same as this guy. So if it's the sum of cubes, the first sign is going to be the sum. If it's the difference of cubes, meaning subtraction, it's going to be a subtraction. And then it's going to be the opposite of that. Right? So I had a subtraction and then an addition and the difference of cubes. And for the sum of cubes, I had an addition, then subtraction. And the last one is always positive. SOAP. So, right? And that's how you can remember the sum and difference of cubes. Okay? Right, it's pretty cute. Let's do some fun examples, and then if we feel the need, we will go back and work at that other one. All right, cool. So we're gonna factor x cubed minus 27. Let me scooch back up so we can like see what we just learned. I have x cubed minus 27. This is where also learning your cubes. I don't know if you guys ever had to learn those. I did when I was like in algebra, I think, when you had to like do them really fast on a quiz. It's very stressful. Did anyone know what 27 is a cube of? It's 3, yeah. So I have x cubed minus 3 cubed. So I'm doing a difference of cubes, right? Because there's a subtraction. So it's going to be x. I have a minus sign. So I'm going to have an x minus 3, right? It's the same sign. And then it's going to be x squared, 3x, and 3 squared. And what's the sign between x squared and 3x? Right here. Right, it's plus, so it's going to be opposite of what I just used. And then what about between 3x and 3? A plus again, right? Always positive. Or always plus if you want to. Think of it like that, right? And then just so it's a little nicer looking, plus 9, which is just 3 squared. Alrighty. Any questions on that guy? Okay. Let's ramp it up. So now I have 8 w to the 6 plus 125 z to the 3rd. So I have 2 different variables. So I would work one term at a time. How can I write 8w to the 6th as some quantity cubed? Oops, sorry. Sorry, Anna. Duke. Duke has been getting very protective lately and growls at trucks, which is very annoying. I get annoyed when my professors go too fast when writing notes in class, so thank you for catching me on that. Okay, how can I write 8w to the 6th as something squared? What do you mean by plus, Hannah Jane? Okay. Okay, I'm gonna scroll back down. So this is gonna go back to when we wanted to do, whatchamacallit, exponent properties a few lectures ago. So w to the 6th, when I want a cube there, I like need a cube there. I know I can do that. I need to put w squared there, right? When I have exponent, a power, and then parentheses to another power, I can multiply those guys. And 8, if you didn't know, is 2 cubed. So I would brush up on your cubes, probably up to like 5 or 6. So I can write 8w to the 6th as the quantity 2w squared, that quantity cubed. All right? 125 is actually 5 cubed. Whee. Yeah. And z cubed is pretty self-explanatory as well. All right. So that's another way I can write 8w to the 6th plus 125 z to the 3rd as 2w squared, the quantity cubed, and 5z, the quantity cubed. Great. How can I factor this? I know I'm going to have a little piece, and it's going to be 2w squared something and a 5. It's going to be 2w squared, 2w, oopsies. Oops, I dropped my z. My goodness. I know, guys. I'm sorry. I forgot the z. Oh my god, now I put too much. I'm sorry. Okay, there we go. Great. And we have 3 spots for signs. Okay, great. So this first one, 2w squared something plus or minus 5z is going to be a plus or a minus. Right, plus. It's going to be the same as what's right here. So plus, same, and then opposite, and then always positive. And since we had so much going on, I'm going to, oh, I forgot a squared right there. Kind of go through and clean it up. So 2w squared plus 5z. Oh, that's supposed to be a squared. Yeah. 4w to the 4th minus, right, that's a squared. A squared, b squared. What is that going to be? 10w squared z plus 25z squared. There you go. Looking at this without sum of cubes, I don't think I would have been able to do that. Remember, the AC method doesn't work with cubics. All right. How are we feeling about sum and difference of cubes so far? Thumbs up, thumbs down, thumbs sideways. Honest answer. Okay, cool. Lots of sides, but we'll be doing lots of other things that require us to use these things. So we'll get more practice along the way. It's a fun thing about math. It just builds on itself. All right. So we've kind of already been doing this by factoring higher degree polynomials. So usually when we think of like a polynomial, you'll think about like ax squared plus bx plus c, something like that. So the highest power is 2. What we just did one was 6. It was pretty cool. But there's lots of ways to kind of help us if I see a higher number, but I want to make it look something similar to what I'm used to, where I have x squared. So we can use that, use a substitution to make life easier, but you have to be careful when you do substitutions. If I give you a problem, in this case, in W, and you do a substitution, your answer needs to be substituted back. You cannot give me an answer with X or T or Z. I need an answer with W. So it's kind of like a translation. If I'm telling you something in one language, you translate it so you can understand it and answer me back in your language, I'm not going to know what you're saying. Your answer is technically wrong. Does that make sense? All right, so I have a W to the 4th and a W squared. So I can rewrite that as, just to kind of give an example of how to do this substitution. I can say, let x equal W squared, right? So then that would make this expression x squared minus 6x minus 16. This looks like a lot more fun to handle than something like that, right? So what can I factor x squared minus 6x minus 16 into? Yeah, minus 8 and 2, right? So x minus 8, x plus 2, and I can double check that. Negative 8 plus 2 will give me negative 16, and negative 8 and 2 add to negative 6. So good. Is that our final answer? No, right? That's an answer in x. So I was given w, so I need to translate back. And I can say that these things are equal because I clearly set up here that x and w squared were equal. So then I would get w squared minus 8 and w squared plus 2. Eight isn't a square, so w squared minus 8. I don't think we can cleanly factor that. So factoring with whole numbers. So I would call that irreducible. I think we factored completely. All right. So it doesn't just have to be just like something squared, right? That's like the common way of doing it, but it can also just be an entire expression. So if I'm given a squared minus 3, the quantity squared, plus 7, a squared minus 3 plus 3. Oopsies. Thank you. What I don't want to do is I don't want to FOIL. The whole point is to factor. FOILing will just expand it out and kind of get me nowhere, right? I can see I have some quantity squared plus something times that quantity. So that looks just like a regular polynomial plus a constant, right? So I'm going to let x equal a squared minus 3. So that would make a squared minus 3 squared, 7, a squared minus 3, x squared plus 7x plus 3. If I tried to FOIL this out and combine like factors and expand and all that kind of stuff, I maybe eventually could get there down the line, but again, work smarter, not harder. Okay. So now what do you guys think I can factor x squared plus 7x plus 3? Can I back this one? Where is it from? Ooh, I wrote this wrong. That is supposed to be a 12. My apologies. Here, I'll write that in black. Right, 4 and 3. Not too bad. So x plus 4, x plus 3. Great. Am I done? Nope. I need to plug in, right? I was given something with A's in it, and I can't answer an X's. It's a different language. So I need to plug in for every X that I have, a squared minus 3. So a squared minus 3 plus 4, a squared minus 3 plus 3. And then I'm going to simplify. So a squared minus 1 and a squared. Okay. Another reason that it's not, I don't recommend like foiling this out and collecting like terms and everything like that, is the more hand calculations you do, more likely is you are to make a little error and everything fumbles from there after that. If you would rather FOIL, I'm not going to stop you. Yeah, that's fine. Two things multiplied by each other. Multiplication is commutative. A times B is B times A. You could get there. You can get there. Just this is a better way to do it. Not a better. That's a really rude way of saying it. It is another route to take, and it might be shorter. Okay. Any questions about factoring and everything so far? Why are we not done? Oh, we're not done. Oh, wait, I did something wrong. See, little calculation error can really mess you up. That's another reason that you should always show your work on homework and exams so that I can just see that you know how to do all of this and you made a little error. I don't have to take off many, like a point at all, really. If I just see that you added -3 and 4 wrong, which I just clearly did on accident. Whoopsies. Another reason to show your work. Okay. How are you feeling about factoring so far? Thumbs up, thumbs sideways, and thumbs down. All right, cool. We have 10 minutes left. So let's kind of just start a discussion about rational expressions, okay? Pull up those notes. Okay. Hold on one second. Oh yeah. Do you guys want to go over that other problem? Where is she? There she is. Okay, we'll do that. And that'll be the last little bit of class. Let me find it so I like don't fudge it up too much. Actually, yeah, let's do that. All right, cool. So we're back to this fun little problem. So I have negative 6x to the 7th plus 6x. Okay. I recommend always seeing if I can factor out some common factors. So what do you guys think I can pull out first? There it is. All right, I got a unanimous 6x. Cool. So I'm going to pull out 6x, and then I get negative x to the 6th plus 1. Okay. I don't like that negative. That's just me. I don't like that negative. So what I'm going to do is I'm actually going to pull out a negative as well. And it'll make our life easier because dealing with something cubed that's negative is kind of gross. So when I pull out a negative, I'm going to have x to the 6th. Is that going to be plus 1 or minus 1? Right, a minus 1. When I pull out a negative, it just switches all the signs. Right? And this helps me see that I have what type of function do you guys think I can do? Difference of squares or difference of cubes? Ooh, Ronald says difference of squares. Abby said SOAP, which is difference of cubes. So which one? How do we decide? Let's do it both ways eventually, right? No. Okay, let's do difference of squares first, right? So we'll do minus 6x, and this is x cubed squared minus 1 squared. So difference of cubes says, so negative 6, that's just going to chill outside. That's not involved really at all. I'm going to have x cubed minus 1 and x cubed plus 1. Well, now that's clearly the difference of cubes, and this is clearly a sum of cubes. So now we're going to do SOAP twice. So this is where I like to use a lot of fun colors. So we're going to call this guy this fun sage green, and this one this fun purple. All right. So I know 6x is just, again 6x, just hanging out there. How can I factor x cubed minus 1. What is that going to look like? I know it's going to take a while for you guys to type that. That is fine. Get our exit slip ready. Someone that's not Abby and Ronald. How can I? Because you guys have answered like everything today. Smarty pants. Factor x cubed minus 1. Anybody out there? What does that mean, Tucker? X plus 1 and x minus 1. Didn't give me a parentheses, so I don't know what those mean. But where are the parentheses? So this is the difference of cubes. Remember, if you look back at your notes, I'm going to have x difference. So I'm going to have the same sign, x squared plus a different sign, 1x plus, and then always positive, right? So that's the difference of cubes. Right, good job, Chloe. And so then the sum of cubes, I can just call and follow the same pattern using SOAP. So x plus 1, x squared minus x, same as 1x. No, you're right. Chloe, that wasn't wrong. Plus 1. So that's that factored. And this is this factored, so you can follow along. Can I factor this anymore? Yeah, you can't factor this anymore. Remember, because these guys, the whole point of that factoring is that this is irreducible. Right. Okay, cool. So we have 5 minutes left in class. So I think this is a good time to do an exit slip. Alrighty. Does anyone need me to stay here? Here, I'll just do my exit slip just right below it. I know, I'm sorry. Page reminder. Okay, it's gonna squish right there. So remember, our exit slips are on Socrative. It's an app, it's also a website. Our room number, our room name is my last name in all caps, followed by 943. I don't know why, that's just what it is. And your teacher question of the day is give me your favorite factoring, what are they called? Formula. So which out of the 5 today that you enjoyed the most? So you need to give me this factors to this and something like that. All right. I started out with 30 of you here. And now I don't have that. Once you complete your exercise lab, you guys are free to go. Remember last name, comma, first name. Just put your favorite formula. Yeah. Like A's and B's and X's if you want. Thank you guys. It's always asking you what you did first, and then like what we did today in the second question, and then the last question is the teacher question. Okay, cool. Remember, you need to complete all 3 sections to get points for your full exit slip. So I know you're actually here. Do you guys still have questions? Let me stop